Hey team, so we are going to be thinking here about how to multiply with decimals. The good news is that if whatever strategy you use to multiply multi-digit numbers, you're going to use the same strategy here. You're just going to have sort of one extra step in there to multiply with decimals. So before you even get going, you want to think about using estimation to help you. So if this is our problem here, right, we want to multiply 1 and 23 hundredths by 4.5, essentially, or 4 and 5 tenths. We want to just sort of know what to be expecting, right? What should our answer be around? What's the ballpark? So we're going to estimate. So we can say 1 and 23 hundredths. Well, the 2 here says that the whole number it'll round closest to is 1, and this 5 in the tenth says that the whole number this will round closest to will be 5. So our answer that we end up with should be somewhere around 5, right? Just a good thing to keep in mind. So now what we're going to do is we're going to set up the multiplication problem the same exact way that we set up any multiplication problem, right? So if we want to multiply these numbers here, 1 and 23 hundredths and 4.5, you can set it up right just in the same way. So if it was a whole number problem, there would be no decimals. So we would set it up as 123 times 45. When we do set it up with our decimals, we set it up the same way, 120, oops, sorry, put it in the wrong spot. So now we have our 1 and 23 hundredths and 4 and a half, right, or 4.5. So what we'll then do is we're just going to multiply like normal, okay? So if it's a whole number problem, right, if you use the traditional algorithm, you would set up your problem and you would say 5 times 3 is 15, 5 times 2 is 10, plus 1 is 11, 5 times 1 is 1, plus 1 is 6. Then we'd say, all right, we've done 123 times 5, essentially, right, which is 615. So now we're going to do 4 times 123, but it's not really a 4, it's really a 4D. So we put this placeholder here, and then we multiply, and when we add them all up, right, we get 5,535. But when we do it as a decimal, you'll see that we end up with the same thing, right? We've ended up with the same exact answer. But what we want to do is we want to remember that this really was not a whole number multiplication problem, right? We really did multiply something where our answer should be more around 5 and not 5,000, right? Because we're multiplying something close to 1 and something close to 5. So we're now ready to place our decimal point in our answer, right? Woohoo, here we are at number 4. So the way that we do that is we can count how many digits, right, are behind each of the decimals in the original problem. So in 1 and 23 hundredths, well, we have 2 digits behind, 2 digits, right? The 2 and the 3 are behind the decimal point. Here we have the 5. So we have 1 digit that is behind the decimal point in the original problems. So when we do that, we have 2 plus 1, which is 3 total digits behind the decimals, right, in the original problem. So what we can do with that information then is we can say, all right, so I've zoomed it in here. All right, we have 3 total digits behind. Well, our decimal if these were whole numbers, right, if it was 123 times 45, our decimal would really be behind here because it'd really be 5,535 and 0 tenths, right, or 0 anything behind the decimal. So when we do have these digits here behind the decimal, what we want to do is we want to whoop, right? We essentially want to divide by 10 and divide by 10 and divide by 10 3 total times, one time for each decimal that's behind the decimal. So we're going to whoop it 2 times smaller, right? And we're going to whoop it 1 time smaller. So our decimal has now moved here, and we now see, we could put that 0 there or not, we now see that we have an answer around 5, which makes sense because our estimate told us it should be around 5. Do be sure to check out these other examples here, and you can kind of set it up and test it yourself, right? And then you have the answer here as instant feedback. This one here can be a handy one to try because you do have to add in a 0 because there's more whoops than spots.